तो एक एफ ऑफ एस माइनस ए वाला फंक्शन रहेगा, एफ ऑफ एस माइनस ए। तो फ्रॉम एफ ऑफ एस माइनस ए यू फाइंड एफ एस, then you find ft, and then you write e to the power at into ft. That will be the Laplace inverse of this. Okay. Okay, now here we will see uh, what will be the Laplace transform of f dash x or f double dash x, or Laplace transform of some integral, means Laplace transform of integration. So why we need this Laplace transform? First of all, means why we are studying Laplace transform? What is the need of it? So we are converging actually again to ODE. The need is in the ODE. Okay, to solve an ordinary differential equation, Laplace transform is a tool. Okay, or is an essential tool, you can say. Why it is essential? Because without knowing the algebraic technique to solve ODs, we can solve an OD. OD में जो भी टेक्निक हम लोग पढ़े थे वो मीन्स क्या बोलते हैं, होमोजीनियस, नॉन होमोजीनियस, देन इनिशियल वैल्यू प्रॉब्लम, व्हाटएवर, मतलब बहुत बहुत टाइप का ओडीज हम लोग पढ़े थे। एंड फॉर डिफरेंट डिफरेंट टाइप ऑफ ओडीज देयर हैव डिफरेंट टाइप ऑफ solving procedures, right? But here we can solve a non-homogeneous ODE with some initial conditions directly by applying Laplace transform. तो मेन गोल क्या है? मेन गोल यहाँ का ये लैप्लास ट्रांसफॉर्म चैप्टर का यही है कि डिफरेंशियल इक्वेशन सॉल्व करना बाय अप्लाइंग लैप्लास ट्रांसफॉर्म। तो फॉर दैट वी नीड एक्चुअली द लैप्लास ट्रांसफॉर्म ऑफ differentiations. Okay, Laplace transform of y dash, Laplace transform of y double dash, that we need. That is why ये सब एक के बाद एक इंट्रोड्यूस किया जा रहा है। फाइन। Do you get it or not? What is the need of this Laplace transform? Finally, where we are going to use it? I can show you. देखो कहाँ पे फाइनली यूज होगा ये। 1 to 11. What is the question? Right. Solve the IVP by the Laplace transform. So these are some IVPs, right? Initial value problems. So you have to solve it by Laplace transform. Now अगर यूजुअल जो मेथड है ODE सॉल्व का वो मेथड में करने चाहोगे तो दैट विल बी डिफिकल्ट बिकॉज दीज आर नॉन होमोजीनियस ODEs, right? Non-homogeneous first order or non-homogeneous second order ODs, and you have learned two methods, that method of undetermined coefficients or variation of parameters. You know how difficult those are. So without knowing those technique I can solve it. और एक एडवांटेज ये है कि ये जो इनिशियल वैल्यू है ना, इनिशियल वैल्यू क्या कब यूज होता है? जब डिफरेंशियल इक्वेशन सॉल्व करते हैं तो आफ्टर गेटिंग द जनरल सोल्यूशन वी पुट द इनिशियल कंडीशन, राइट? In ODE, how to solve initial value problem? After getting the general solution of the ODE, we put the initial value na, to get the value of the arbitrary constant. Are you getting or you forgot everything?
Yes, sir.
तो यहाँ पे और एक एडवांटेज ये है कि ये इनिशियल वैल्यू जो है ना, you no need to apply it separately within the process. uh, they will ask for this value. Means the process will ask you for this value, no need to apply it separately. Okay, now let us see how to, means what are the formula for derivatives. See, that is a formula for first derivatives Laplace transform. Laplace transform of f dash. Okay, means f dash means f dash x, not x. Here we took the variable t, so it is Laplace transform of f dash t. Fine. So what it will be? It is s into Laplace transform of f minus f0. You have to remember this formula. There have a pattern. I will show you the pattern. So Laplace transform of f dash, it is s into Laplace transform of f minus f0. Laplace transform of f double dash, it is starting with a square. ओके, डबल डेरिवेटिव होगा तो ए स्क्वायर से स्टार्ट होगा, सिंगल डेरिवेटिव तो एस से. सिमिलरली यू कैन टेल मी लैपलास ट्रांसफॉर्म ऑफ एफ ट्रिपल डैश, वो कहां से शुरू होगा? एस क्यूब, एस क्यूब एल ऑफ एफ. फाइन. तो first of all I'm telling you the formula for f double dash. Laplace transform of f double dash, it is a square Laplace transform of f minus s f0 माइनस एफ डैश जीरो. एफ डैश जीरो मतलब डेरिवेटिव का एट द पॉइंट जीरो पे वैल्यू. तो क्या होगा कि ये जो पैटर्न है, जितने ऑर्डर का डेरिवेटिव है एस का पावर दैट वहां से शुरू होगा. एंड फर्स्ट टर्म ऑलवेज कंटेन लैपलास ट्रांसफॉर्म ऑफ द फंक्शन. देन ये एस का डिग्री एक एक करके कम होता जाएगा. एंड एफ, एफ जो हो रहा है यहाँ पे, एफ का डेरिवेटिव्स एक एक करके बढ़ता जाएगा. तो by using that rule, what will be the Laplace transform of f triple dash? Can you tell me? Laplace transform of f triple dash. Look, I'm not discussing the existence criteria for this Laplace transform, provided I'm assuming that it satisfies the existence criteria. मतलब ये सब केस में Laplace transform exist कर रहा है, ये assume करके ये formula बता रहा हूँ. तो can anyone tell me Laplace transform of f double dash? Sorry, f triple dash. You generalize it. S cube L of f. Okay. Next term will be a square. A square f 0. Next term s f dash 0. Next term f double dash 0. Do you get it?
Yes.
Yes, sir.
Look, power of s, the exponent of s, it is gradually decreasing, started with 3. Okay. And you can see that the number means Number of differentiation of f0, it is increasing. f0, f dash 0, f double dash 0. तो ये कब कहाँ पे रुकेगा एक्चुअली? nth अगर nth डेरिवेटिव का लैपलेस ट्रांसफॉर्म निकाल रहे हैं, देन कहाँ पे जाके रुकेगा ये? n minus 1th derivative at the point 0, right? So you can see the generalized formula for this Laplace transform of nth derivative of f. This ये एक ही फॉर्मूला याद रखने से पर्टिकुलर केसेस 1 2 3 वो सब लिख सकते हो. ओके, so Laplace transform of fn. Fn means nth derivative. So it started with s to the power n. So s to the power n Laplace transform of f माइनस देन s का पावर जो है वो ग्रेजुअली डिक्रीज होगा, s to the power n minus 1 associated with f0, then next term minus s to the power n minus 2 f dash 0, then s to the power n minus 3 f double dash 0. In that way the last term will be f n minus 1 0. Okay. So you have to remember these two at least, क्योंकि we will solve second order OD. Okay, and in second order OD there are double derivative. So ये double derivative and single derivative, ये दोनों formula always remember. Always you remember. Okay, Laplace transform of f dash, Laplace transform of f double dash. So these are formula related to differentiation, Laplace transform of differentiation of some function. And another formula, it is related to integration. So Laplace transform of integration. So that integration will be of some particular specialized form. Not every type of for every type of integration we can find the Laplace transform. Only we can find the Laplace transform of integration 0 to t f tau d tau. Okay, only this type of integration. For this type of integration we can find the Laplace transform. So Laplace transform of this integration, देखो f tau you can write also 0 to t f t dt, कोई इशू नहीं. एक्चुअली लिमिट में t लिखा है ना, तो इसीलिए वो t वेरिएबल दोबारा इंटीग्रेंड में नहीं लिखा है, तो दूसरा वेरिएबल लिखा है. बट यू कैन राइट 0 to t f t dt. तो Laplace transform of 0 to t f t dt, what is the formula? It is f of s divided by s. f of s divided by s. Now what is that fs? ये fs है, ये इंटीग्रैंड जो है वो इंटीग्रैंड का लैप्लास ट्रांसफॉर्म, मतलब ये ft का लैप्लास ट्रांसफॉर्म है fs. ओके, so if you know the Laplace transform of small ft which is assumed to be capital Fs, then Laplace transform of 0 to t ft dt is equal to fs by s. So what is its inverse form? So Laplace inverse of fs by s, it is 0 to t f tau d tau. Just l right side में चला जाएगा तो l inverse. So l inverse of fs by s, that will be integration 0 to t f tau d tau. So from now on, if a function is given in the form something by s, we will apply this formula. Okay, if a function is given in the form something by s, or we can express it in the form of something by s, then we can find the Laplace inverse of it by that integration. So what we are doing actually in the means Laplace transform directory, you can say we are adding one by one formula. So in this chapter, these are the main formulas here. Laplace transform of this, and it's an inverse form, and Laplace transform of derivatives. Okay, this. Now see, we will solve ODEs by that Laplace transform of derivative formula, but there are some other use also. I'm showing you. Uh, I'm coming to exercise. So it is asked in problem number 17. Laplace transform of t e to the power at. Okay, that is a very simple one. You can apply uh, what is shifting theorem, isn't it? Laplace transform of t e to the power at or minus at, e to the power minus at. Can you tell me by s shifting what it will be? Here ft is t, na? So what is the Laplace transform? Ft 1 by a square. देखो और थोड़ा सा तेज होना पड़ेगा, इतना स्लो होने से नहीं चलेगा. मतलब जब भी मैं फॉर्मूला पूछ रहा हूँ इमीडिएट वो बताना चाहिए कि क्या है, नहीं तो प्रॉब्लम कैसे सॉल्व करोगे. Here ft is t, then Laplace transform of t, it is 1 by a square, right? And here a is our minus a, so is not it 1 by s plus a whole square? By s shifting. Now they have given this function in this chapter t e to the power minus at. Actually, they are asking you to use that differentiation formula. So, can we use the differentiation formula to get the Laplace transform of it? देखो कैसे हो रहा है. So, ft it is t into e to the power minus at. We are assuming. Don't compare it with the s shifting form. In S shifting form, e to the power at into ft, ft is t. Here we are taking total function as ft, t into e to the power minus at. Now you differentiate it. So differentiating, what we are getting? Tell me. E to the power minus at minus a t e to the power minus at. Any doubt?
Yes, sir, sir.
After differentiating it one time, I will take Laplace transform. So how do I fix that? Ki, how many times I have to differentiate it then to take Laplace transform? How to fix that? तो तुमको ऐसे फिक्स करना है कि when that same function ft is coming after some certain differentiation in any term the same function is coming, then you stop there. You see ft is t to the power minus at, and after first order differentiation we are getting that same term, right? So here I will stop. Now we will take Laplace transform both side. So Laplace transform of f dash t, it is Laplace transform of this right side, e to the power minus at minus a into Laplace transform of t e to the power minus at. Okay. Now you put the formula for Laplace transform of f dash t. What is it? S into Laplace transform of f, right? Minus f0, यही फॉर्मूला था ना लैपलेस ट्रांसफॉर्म ऑफ एफ डैश टी का. एस लैपलेस ट्रांसफॉर्म ऑफ एफ माइनस एफ जीरो. नाउ व्हाट इज एफ जीरो? एफ टी टी ई टू द पावर माइनस ए टी है ना, तो टी की जगह पे जीरो पुट करने से क्या मिलेगा? जीरो. सो एफ जीरो इज आवर जीरो and Laplace transform of e to the power minus at, that is 1 by s plus a, and a into l of f I can write. वही सेम f मुझे मिला है ना, t into e to the power minus at, that is f. Now just you algebraically solve it. तो it will be ये जो a into lf है इसको लेफ्ट साइड में लाओ तो it will be s plus a into l of f is equal to 1 by s plus a. Then l of f ये क्या हो जा रहा है? 1 by s plus a होल स्क्वायर. तो यही तो करना था ना लैप्लास ट्रांसफॉर्म ऑफ एफ टी. Do you get it? What is the application of this derivative? मतलब ये डिफरेंशिएशन कहाँ पे यूज हुआ?
Yes, sir.
देखो by s shifting you can write it directly, but there are other way also, alternative way. By using differentiation of function you can find the Laplace transform. Okay, in the exam if it is asked find the Laplace transform of some function, always you follow the shortcut way, right? Why unnecessarily you will do that alternative method? It is lengthier now comparative to s shifting. So एग्जाम में आएगा तो सेकेंड मेथड जो मैंने बताया ये उतना यूजफुल नहीं है, एस शिफ्टिंग ही बेस्ट है. बट ये जस्ट दिखाने के लिए कि एफ डैश टी यूज करके भी लैप्लास ट्रांसफॉर्म ऑफ एफ टी निकाला जा सकता है.
सर
हाँ यस.
सर ये मिड सेम में नहीं आएगा ना?
नहीं ये मिड सेम में नहीं आएगा, बट ये सीख लो अभी, नहीं तो अभी सोचो मिड सेम में नहीं आएगा तो नहीं पढ़ेंगे, तो बाद में तो दोबारा मैं नहीं पढ़ाऊंगा ना, तो सीख लो, बट मिड सेम में नहीं आएगा. ओके.
यस.
That's all for today. In the next class, I will show some other applications of derivatives, and then we will solve some ODs. I'll give all present. Thank you all.
Okay, sir.
Thank you, 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 sir.